we are going to start with our first session panel discussion on connecting the dots for energy positive buildings and campuses, experiences sharing by key stakeholders. Now I would like to invite Mr. Tanmay Tagatat. He is from USAID SAREP for the moderator. Welcome you, sir. May I also invite all panelists for this session, starting with Ms. Mili Majumdar. She is a Managing Director, GBCI. Welcome, ma'am. Now, I would request Mr. Abhishek Gupta. He is a Head International Strategy, Appliances, Rooftop Solar, and PE and EESL. Welcome, sir. I would like to invite Mr. Sujay Saha. He is a Head ESCO and HA, New Business Services, Tata Power Company Limited. Welcome, sir. Now, I would like to invite Mr. Girish Ghatikar. He is a advisor at ISGF. Welcome, sir. I am handing over the session to Mr. Tanmay to take this session forward.
We've all have the context. We know what energy positive habitats mean, hopefully by now, and the discussion on examples and policies and all of that has happened. I think the focus for this discussion, what we should try to get out of this panel here is how does it actually materialize? How does it change from a concept to reality with the Indian context, with our lifestyle, with our resources, our constraints, and our rapidly changing energy scenario, which is more dynamic than most places in the world. So we have the right set of experts here. But before we start, I think, Girish, you wanted to make a presentation?
Anytime. I'll make a presentation, but I don't want to skip the order.
No, there is no order. So if that will help, it'll be better that you get it out of the way, then we get on to with the discussion. So yeah, take a few minutes and do the presentation.
Okay. Well, let me introduce myself. I'm Girish Ghatikar. I am an advisor to India Smart Grid Forum, but my main bringing the food on the table work is with General Motors, GM, if you ever heard the company, United States. I am a fellow there, trying to kind of create a new business opportunity for GM in the GM energy side of things. All the great things that some of the folks have spoken, including Reggie this morning on electric mobility, V2G, battery, etc., are part of my initiatives. But my work with the energy efficient and grid interactive grid responsive buildings goes back over a decade in India when I was a project director leading the DOE programs for India in the activity called grid responsive buildings. For those who have been here for a long time to really understand the US-India partnership, including USAID effort that are happening here, they are classified at two levels. One at the research area and the second one is in the deployment area, right? The research where, a lot of technology need to be contextualized to the Indian weather, Indian culture, Indian buildings, etc. Some of the things that Tanmay mentioned. And both Tanmay and some of the folks here were part of that project as well. It was called the Center for Building Energy Efficiency Research and Development, or CBIRD in short, as part of the US-India partnership. I was the project director on the US side leading that project. We worked very extensively with a lot of buildings. We looked very closely with respect to the Indian needs and how technology can be transferred. And more importantly, linking up with the other aspect of the buildings on the deployment side that USAID led. The research was led by the DOE, and the deployment was led by USAID. So we kind of collaborated very closely. And both of these are crucially important for the discussion we're going to have today. So I'm not going to talk about all the details, but will give you a little bit flavor on the broad context of what are the key considerations when we think about US-India collaborations, It's not about just bringing US technologies or US companies into Indian market and deploying technologies here, but really understanding the Indian context and making sure that we have technology that is rightly suited for the Indian conditions. So if you look at a very high level, right, 30,000 feet level, we looked at this, and by the way, I do have reports here, 50, 60, 80 page reports if you want to read in more detail. In the US, right, it's primarily a retrofit market, and this is, we are looking from a commercial buildings. And we had, at least this is around 10 years old data, okay, but still very relevant. We had over, 10.3 billion square meters of construction of commercial buildings in the United States. So if you're, and the new construction growth is not as fast as the existing buildings, because a lot of commercial buildings are already built in the US. So where do we focus? We focus on the retrofit, as some of the earlier speakers spoke about. How do we identify energy efficiency opportunities in existing buildings, and what do we develop new technologies, let's say air conditioners or lighting controls or new technology with sensors, etc. How do we create new energy efficiency in the retrofit buildings? And the technical target there, we were looking into business as usual scenario, which is the top orange line that you see, versus the target that we think we could achieve with retrofits of energy efficiency. We could have potentially gone down from almost 3,500 terawatt hours of energy use, close all the way down to 2,000 terawatt hours. That's around 36% savings from the time we started in 2010 all the way down to 2030. Now let's come to India, right? When you look at India, the commercial stock is almost 1/5 of the commercial stock in the US and growing very fast. It was just like 1.9 billion square meters at that time, but huge potential to grow in commercial building. So the focus there is new construction, right? How do you create buildings that are efficient? How do you design buildings that are efficient? How do you work buildings that can be grid interactive? Was the biggest question for us. And when we reviewed the existing building stocks in terms of efficiency versus what we can potentially or technically save over a period of 30 years, we could see that from over 500 terawatt hours of energy use, we could bring it down to close to 300 terawatt, right? So that's 40% savings. So if you really design your buildings very efficiently and continue to build them very efficiently through energy modeling, passive design that were spoken earlier of how to use most natural light, etc., you can save a tremendous amount of energy, and those buildings can be efficient right from the design and right from the construction. So that was the second very important lesson that we saw in India when we started thinking about what we can do. And real estate becomes very important. Can we construct buildings that are efficient, and will that motivate people to move into those buildings? The buildings are not only safe, but they're also very efficient. So in terms of the trends that I'm seeing, right, all of that work that we had done over a 5-year, 6-year period, if I have to summarize that into 6 specific ones, and I will talk about 2 aspects that are critical from the term smart. What makes the building smart, right? So smart can also be a very misused term, just like net zero is and was in the past. First aspect is design efficiency for retrofits and new construction, right? So there are retrofits that you can potentially consider, but if you want to really prioritize new construction in India, makes a lot more sense. Within that, the energy efficiency modeling and design becomes important. And when you think about retrofits, you're talking about commissioning the buildings. Commissioning is nothing but where you install equipment, your building monitoring systems, commissioning systems that can operate in the parameters that you have set. That's the commissioning part. The second is retro-commissioning. Retro-commissioning is where we go back into an existing building and see if the building is tuned enough and the control systems are working the way they're supposed to be. If they're not, what can we do to improve energy efficiency in the retrofit? And the third is the monitoring-based commissioning, MBCX, right? That's where we look into continuous iterative improvement. Somebody spoke here earlier that said, hey, can we audit these buildings on a real-time basis? It can be net zero, it can be efficient when it was designed or when it was constructed. Is it operating every day under those efficiency paradigm? What happens after a year, right? Is it continuing to operate at the same efficiency? That's where the monitoring-based commissioning becomes very critical, because if I might change 1 degree temperature set points at one zone, it might affect other areas. What does it mean from the energy efficiency perspective? The second is design for inherent demand flexibility. Again, this is also a term that is used very extensively. I like the term demand flexibility or demand response more than something that says grid responsive or grid interactive, etc. But the demand flexibility is something that we look from what is that demand? Is it an air conditioning demand, whether it's a lighting control demand, whether it's EV demand, or whether it's your energy storage, battery storage demand? How do you look at those strategies to lower cost, carbon, and potentially energy? When we're talking about demand reduction, it's very important to understand we are not thinking about energy savings. We are talking about when that energy gets used, right? You can potentially use the same amount of energy, but use that when the grid is stable, not when the grid is congested. That's 2 minutes, right? The second one is non-fossil based distributed energy. So make sure that you run it in a clean energy. Third is use technology and communications. Buildings are becoming extensively technology savvy. And then finally, building codes and partnerships, right? Building codes is very important in US. One of the strong building codes is Title 24 building code, and how we can replicate that building code strategies into grid interactive within the energy conservation building code is a very important question to answer. So this is just an example of California loading order, where energy efficiency is first, demand response comes first, and all the other aspects before new, generating plants are being built. So I'll move on in the interest of time. These are some of the lessons that we worked on a grid responsive building. There are a lot of technology opportunities for collaboration, improving cost efficiency, regional partnerships, technologies, and public-private engagement. This won't happen until you really have a public-private engagement between two countries and the public and the private sector to work. So looking from a long-term perspective, immediate perspective, near-term perspective, what are some of the key technology aspects? The more higher you go long-term, that's where the R&D becomes more relevant. The more near-term you do is the ready available technologies, and its deployment becomes very important. Talking about deployment, we worked with one of the US companies to apply some of the US technologies like OpenADR standard for grid communications and making buildings more grid interactive, and creating an opportunity. This is where we work with Tata Power. Sujay was part of that project as well. We looked into using US technology for automated demand response project. It was the first project in this country that looked at applying this technology, and we could reduce 16 to 18% industrial and commercial buildings peak demand, and average around 10% on 128, 130 buildings that participated in this. And we created M&B platform. So the lesson here is there are technologies that are ready that can be deployed for energy efficiency immediately. Consider them, but at the same time, take a look at the data. That's very critical. We can speak and create a lot of presentations, and we can continue to do that for another decade. But the important thing is if we can look at the data, identify the opportunities, and try to scale up, that would make a significant difference in addressing these grid responsive and efficient buildings. Thank you very much. Yeah.
Thank you. Thank you. I think this was an important aspect of understanding where the whole discussion on energy positive, demand flexibility, and technology needs to go for us to realize this vision of, I would say, the larger vision of net zero for the country. So, if we have to understand this better, I wanted to start again with Mr. Bali. You discussed, you presented this whole idea of looking at grid optimal metrics. I think that is a first step to understand how a utility needs to understand buildings and what are the possibilities of making those changes. So, but in our current status of smart grid development, how far are we from getting there? The work that is happening, for example, with smart meters, do you think that is one step in that direction and will lead us to there? So what are your perspective on, from a utility perspective, what needs to be done, and how does our current work of smart meter figure in this work, in this process?
At the moment, if you go with the primary building block of smart grid and as such altogether, what you're talking about, the grid optimal matrix developing of that, I think the utilities or the states have been going ahead with this, I think, disruption in the case of this metering, and that too with the smart meters. And I think utilities like Bihar, MP, UP, and even the Assam, they are basically taking a lead in that. And since the smart meters are in place, so that gives a very basic building block of that. We can have a real-time information. We can have the entire their proposition and actually what's going on at the moment in their utility. Earlier, we used to have data that is being relied through the ledgers and other thing. We have to rather encapsulate that in a very long time. And we have been interacting, as you see, we have been talking with the MP and Haryana, and that has taken us some time to build up that. How much progress has been made, I think that can be discussed about that. But keeping that in mind, I think that gives a basic thing, and that's the starting point to develop that matrix. And of course, that gives the insight of certain buildings they have come about, that where they have a critical load and where is the load which can be offering us the flexibility what we are talking about. And that need to be identified. That is the first stage of having the development of the matrix. Second thing would be coming, I think Girish has mentioned regarding the retrofitting of that. But in our context, how that will be done, then comes the play of this technology. How we can fit into that. There can be equipments, there can be certain technological interventions. Through that, we can rather manage or make them grid flexible ready things so that actually we are able to deliver. In that respect, I think this development of the matrix, development of their condition and development of the spare use, as we say, the net positive generation out of that. Because first stage would be, I think the Tata Power example has been given, but in that case, I think the trigger has more so on the basis of demand response, where these critical load can be shed on based on signals. And while sending signals, I think the prime thing which we are having at the moment is a very good thing and right time, that is a smart meter. Through that, I think that is a very opportune thing to happen. So keeping that in, first we have to identify the loads, first we have to identify their demand response pattern and the peak and how much we can contribute, and then taking the signal and how to give that, then it will be coming the play of the, you can say, it can be an aggregator on that point of view, how that will be sending signals and managing that, and then making that interact according to that. So that is the basic thing.
Thank you, and thank you for bringing up the point of the aggregator. But before we discuss that specific point, I wanted to just take a reference from what Girish, you said, that if our smart metering infrastructure is expanding, and we have these some test projects that have been done. So from your perspective now, what should be the next logical step from the, when we have the smart metering infrastructure, specifically with respect to the interactivity, the communication, software protocol, what needs to be done to enable that, taking from examples of what is currently happening as pilots in US and other places in the world?
So thanks, Tanmay. Let me step back a little bit when we talk about smart meters, right? The Tata Power project I mentioned, we did have smart meters at that time. I think in my view, what's happening in the US, and it's very relevant to India, the smart meter is extremely useful in 3 levels, right? One is getting the real-time data to really understand how the building energy use is being used at the building level, at the whole building level, right? It doesn't measure your HVAC efficiency, or it doesn't measure your lighting efficiency, but it does measure your building efficiency. So as a starting point, really benchmarking the overall energy efficiency at the building level, I think smart meter data is going to be critical. And this is where we are seeing new companies using artificial intelligence, et cetera, data analytics, to identify, disaggregate these loads using NILM or non-intrusive load monitoring techniques. So that becomes a very critical piece. The second aspect is monitoring-based commissioning, right? Is the building that was programmed to operate at a certain parameters, a certain metrics, is it continuously working in that? And the smart meter data, whether it's 15 minutes interval data, hour interval data, will help you continuously monitor that. And for me, the third and the important thing which we used in Tata Power project was, which we haven't touched extensively, is measurement verification of demand response. We can create grid signal, we can create demand response strategy, we can create all of these things, but it doesn't matter if you can verify its impact on the electric grid, right? Because demand response, the biggest value to it is improving grid efficiency, not building efficiency, but grid efficiency. That's where we applied a lot of MNV models, and using smart meter data to validate, yes, building did perform, it did impact grid. And that's what the numbers I mentioned, 10% overall grid demand reduction over a performance of a building. So I would say those 3 levels, bringing in those MNV techniques, modeling techniques, I think will be very critical when we look at the smart meter data. But you also mentioned the protocols, right? In US, one of the things we learned, and that came out of my research when I was at Berkeley lab, a DOE lab, is we need standardization, because every building systems are different, every utility is different, every utility demand response program design and tariff is different. And if you start designing every control systems and every program according to that, you're not going to roll out the program. So standardizing that communication become important. That's where the open standard, open EDR came out of that research. It's a national standard in the US. It's even in building, Title 24 building code in California now, mandated with the language. All California utilities and other utilities have to use it. And fortunately, BIS also has adopted it in India as one of the Indian standard. That came out of some of the work we had done here in collaboration with the US TDA, USAID, as well as DOE. So I think creating that common mechanism so the building controls are ready to receive grid signals to act upon is a very critical feature, which is what I call it as demand response ready buildings, right? How can you even design and have buildings ready that are not only efficient, they also can receive and act upon those signals when a utility makes those programs, right?
Thank you. Yeah. I think you've raised exactly the right points and also pointed us to the steps that are needed to be taken. But I wanted to now put it to the test of an actual utility, and that's working and that's facing these all other challenges at the same time. So Sujay, from this perspective, what are the, if we have to implement, this is one step beyond demand response. This is demand flexibility, where you may even have a storage that is coming back to the grid and all kinds of other things. And you've piloted some of these. What has been the experience, and specifically, what are the key challenges that you face in first, implementing these things, and second, scaling them up?
So, to add Girish, that the smart meter part. So smart meter, rightly Girish mentioned that it is for the MNB and the load profiling, because you should know that that helps the smart meter data helps to get the load profile data, what the right time for the conducting the event, trigger the event, okay? And the smart meter, the protocol is different than the other protocols. So getting integration with we have done the integration, but there is very complex and the lot of the technology interventions and the cost also to that. So better to, the smart meter data will help to the which segment of the customers to be for the eligible
target.
for the
Yeah.
ADR event, and also validation part, MNB part. And but I think that can work as a separately with some back level integration, data level integration to help the ADR rollout. Even we have done the recently we have done the Imperial College UK, the one pilot for the residential customers ADR. First time in India we have done the ADR residential in Delhi and Mumbai. We got 10% reduction in the residential, and this is a completely behavioral kind of that give them
Right.
for the scale up. So what is the time and what are the notification, day ahead notification is useful or the short notification is useful? Even the, what kind of the incentive, what duration of the actually event is actually customer participate more. Those are things, and the appliance, which are the appliances actually the giving the more impact for the
Right.
ADR events. So we got those data, that reports to be come in the June in this ADR, residential ADR. And in addition to that, mainly the support from the regulatory side that because these things, if you not, the regulatory framework is not there, implementation challenging, because otherwise it will stop at the pilot stage only.
But isn't there the regulatory framework already exists now?
ADR, see the incentive kind of thing.
Incentive, yeah, exactly.
Yeah,
the incentive part is not
not there.
clear.
Clear,
It's
yes.
there,
But see, if you give the incentive for the energy, ADR is not the energy savings, it is a peak load savings.
Exactly.
So that peak load incentive should be that much significant that customer, who are the users, they participate, and this the ADR. And for the Tata Power point of view, we have done a lot of the building side and customer demand side, like that. The EV charging, we have rolled out a smart EV home chargers, so that if you plug on the EV, so it will run for the completely night
Yes.
hours. And even the charging is completed, the onboard charger consumes lot of power. So we have we have the Tata Power first time doing the IoT solution. We have our own IoT solution, that is Tata Power ISUW. Around 20,000 plus customers we are having pan India. So this is the first utility going for the inside customer homes, and for the controlling comfort and convenience. Other than the comfort and convenience, we giving the smart energy management. All the individual appliances are actually, you can measure the energy, how much energy is consumed, which are the appliances contributing your electricity bill. Even you can like a slab, getting the slab benefit, you can set the threshold and
Yes.
control the appliances accordingly. So
Great. So I think those are two very important points. I think one you're saying is smart meter is not necessarily the only gateway for managing these programs, but it's also first use is to identify the load and the customer and the profile. And the second thing is that I think from what I can gather is that in order to make this demand response or flexibility program, you have to bundle it with other things that are of customers' interest
actually,
directly, and not necessarily single point for only one event, because it becomes like a smart home or a smart building solution in which this comes in. And this brings us to how do you scale it up? So from the experience of doing all kinds of energy efficiency projects, Abhishek, I know this is a subject close to your heart. You've been looking at actually implementing and scaling demand response, demand flexibility projects, and we have seen that these challenges that come out still exist. So from your perspective, how do you envision putting it all together as becoming that facilitator, that aggregator? Because we really now see, and I'll come to Mili in the end, because the building side is a completely different animal. But from a utility side itself, there are a lot of issues, technical challenges, regulatory needs clarity in some of incentives, and how do you do this, hardware, software. What is your vision? How do you think ESL plays a role in scaling it up, in making it into a viable business?
Thanks, Tanmay. I think we heard about the significance of measurement, verification, doing the initial monitoring. But what is more important is the customer awareness about it, what we have seen as an organization. We have been doing our bit to, put up energy efficient equipments in the homes of people through our interventions, be it lighting, cooling, and many more. What we have seen that the point what Mr. Sujay just explained about the money, what is going to be paid or saved by the customer, because that is actually what we have seen being the main driver of our consumers in India, because we are very, very price sensitive in terms of, or money sensitive in whatever we do. So naturally, a regulatory aspect is something which would be an important thing for us to understand how much regulation enables the DISCOMs to pay to the customers. Another thing which could be important for us to understand is the platform, because DISCOM is working in one way, utility is working in another way, customer is already there, then we have the regulator and the technology provider again. So for putting all these players on a single platform would be important to get the transformation actually seamless. And we at ESL are actually working on that. We are developing our own platform to cater to DR specific solutions, wherein it is not the specific set of technology which would be on the platform, rather any technology which helps to cater to demand response would be welcomed. We would be talking to different utilities, and Tata is definitely amongst the prime utility which are very progressive. We have been talking to BSCS and so many other utilities as well to go forward and make it a platform which is dynamic enough to cater to the requirement of not only the utilities, rather the customer as well, because customer can also see it as an incentive to them for being more agile and informed to get the overall net zero thing. In fact, it is something which can be an able contribution from the end customer as well. So though the bits and pieces of energy efficiency is something like, I give an example. Today I think Apurva, I shared with you that we are opening the price bid for our 20,000 super efficient air conditioners having 5.8 and 6.2 ISCR rating, while 5-star is sitting at 5.0. We did the fan tender of 20 lakhs and we got the best ever prices. But these are the areas which we have been doing on product side. But home-based solutions, integrated solution is something which should be important to be the right solution for demand response actually. So we are heading towards that, and the way we are progressing, I think by this year end, we'll be having some solution towards that as well.
Great to know that, there is from a actual implementation and scale up as a viable business, there is optimism. But I think I wanted to come back to Mili in the end, because, you have worked on the building side from the time that the concept of passive buildings and other things started getting implemented. And you've done part of net zero buildings. So here the question for you is that, when we are looking at now net zero, and the discussion on today is positive, not just net zero, you're in fact going beyond that. And the utilities are going to look at it in a very different way. They have their, but if it has to be standardized, if ESL has to start making a business out of it, if there has to be incentives, there has to be a standardization, there has to be a metric, there has to be a way that everybody does not start with their own hardware, software, and analysis of what is energy positive and what is not. So what are the global standards? What is happening in terms of energy systems, building systems, to standardize this thing, to certify these things, that becomes a baseline for doing any other work in this sector?
Yeah, it's a long question, and I don't think we have so much time. So, I think I'll try to keep it brief. In summary, because I have been, as you said, in trying to develop standards and benchmarking and rating systems per se for green buildings, and out of which energy efficiency, net zero is one component. for several years. So, and I feel rating systems are very good reflection of what the market can absorb. So, in my experience, I would like to segregate new buildings from existing buildings, because people who design and construct buildings are not the ones who operate buildings. So there is a huge disconnect between what you talk at the design stage and what you talk about the operational stage, where the utilities and others come into being. Having said so, in the rating system also we see this distinction. So when we talk about new building construction, right now, we are progressing towards more and more aggressive targets. If you really see, ECBC has also progressed. ASHRAE has progressed several, notches to promote more and more energy efficient building, which will be super efficient from inception till now. And then now we have also brought in concepts of, within the new buildings, about embodied emissions. That how do you define a net zero building when you are designing it? There you talk about embodied emissions, you talk about operational. And also if you go to places like Europe, you would see their standards also talking about biogenic carbon, because you have a lot of wood-based construction. So the definition of net zero buildings become, very profound when you look at new building. And the standards are evolving very fast, and the scope of defining net zero is increasing. But having said so, even for a rating system, we have to take a step back. Though we have the knowledge, if we roll out a rating system which is very progressive, we see that, say, in markets like US or particularly Europe, there is a lot of adoption. But if you come to countries like India, you do not see adoption because the market is not ready. For example, if you talk about embodied emissions, you do not have enough material that have environmental product declaration which can talk about. So there is a variation in that. And also in this landscape, we see how people interpret rating system. Just to give two differences between US market and India. In US, we talk about buildings now getting more and more electrified and, moving to electrification of buildings and making the grid greener, and hence going towards net zero. But in India, that's not the case, So there's a very large difference. So that's on the new building side. And these are the emerging things, like talking about embodied emissions, talking about less and less operational carbon, and also looking at, all scopes of emissions holistically. And then trying to see how you are able to, because still you cannot construct a net zero building, so how you offset by on-site renewables, or procuring renewable from off-site, and carbon offsets, which again remain a controversial issue because it is not accepted, within SBTI and other frameworks, and also within federal regulation, but in India it is accepted. So there is a large market variation. Now when you come to existing buildings, there are, again, we operate two net zero programs. One is a net zero carbon and a net zero energy. This is also very diverse. In net zero carbon, we look at emissions also from how people commute to buildings, and looking at net zero emissions from there we do not look at the embodied part, because in existing building, if a building is constructed, if you have not considered embodied, then you cannot account for that or offset that. So there is a different dialogue on what you kind of capture. And there is another rating program that we operate, which is called net zero energy, which we look at only the source energy that is consumed within the building, and how you offset by renewable there. So the definitions, what even we have laid out as a ratings agency, in the LEAD program, is also varied, and it's also very, and that reflects what the market accepts and responds. So it's a very good reflection board. So my conclusion would be that, that we have to be careful when we talk about net zero and define it well, and then see what we are trying to achieve. And it can vary very largely, from one to another.
Thank you, Mili. So you're saying the metrics are available, but they need to be ready for adoption. And the exact definition that is global may not work in every context. And I think this is a reflection of a lot of what we heard. Now, we are absolutely out of time, but I still wanted just the last one bit from all of you, just in one sentence. that if you have to connect the dots from where we are today, from your perspective, to becoming a net zero, plus not just net zero and energy positive, and specifically from a building sector perspective, what would be the key solutions or the key next steps in doing that? So, and I'll start with Mili, you first. One sentence.
Yeah, I think the user perspective is very important, who are designing for, and they should understand, you know, and kind of have those use cases in place. Yeah.
Thank you. Sujay?
For me, I think that it should be a simple IoT solution, take the benefit of the IoT solution available, the getting the, so that the and also enhance financial benefit they should have with affordability.
Girish?
So Tanmay, one thing I can think of looking from the demand response side of things is identify the value to the grid. Otherwise, the grid interactive buildings are not going to work. So how do you create a value to the grid is going to be very critical.
Abhishek?
Let people be more aware about it.
Okay. And finally, Atul ji, aapke hisab se, what is the key thing to connect it to energy positive from where we are?
I think key thing is demonstrating it, doing a pilot, a real pilot. The time has come, we have to showcase. As the Tata Power has shown something, we have to actually demonstrate it at the site. I think that is a simple thing.
Great. A big round of applause for the panel. I think in the limited time, we got a lot out of them. Thank you so much. And I think this work is in a very exciting phase where I think pilots have been done, challenges have been identified, now solutions are on the deck, and we are ready for doing demonstration, hopefully scale up as a business. So thank you all. Over to you, Bharat.
Thank you everyone for the insightful presentations and valuable contributions on energy positive buildings and campuses. Now I would request Ms. Reena Suri to join us on the dais to hand over the token of appreciation to all speakers. Starting with Ms. Mili Majumdar. Mr. Abhishek Gupta. Mr. Sujay Saha. Mr. Ghatikar. Mr. Tanmay Tathagat. Miss Apurva Chaturvedi. Previously was there. Now I would request panel to join us for a group photo.